Good afternoon. Welcome back to our the basic chemistry of the first year intermediate. Today we will see the new chapter S block elements. So S block, everybody knows the group 1. Group 1 and 2 belongs to S block. Right. What are the elements in the group 1, 2? First we will see the group 1. Group 1, first one is lithium fellow, then sodium, then potassium, rubidium, cesium and francium. And electronic configuration outermost, if you see, this is the number 3. 3 means it will be 2s1, 1s2, 2s1. This will be the outermost is 3s1 because 3 plus 8, 11. 11 plus 18, 19 means 4s1. Then here it is a 5s1. It is a 6x1, 7s1. This fellow is radioactive. Radioactive. That means outermost 1s electron will be there in the group 1. That is the electronic configuration. These group 1 elements are called, normally called alkali metals. They are all metals. It is called alkali metals. Why alkali metals? Why alkali metals is they give the, on reacting with the water and all, they give the hydroxides. Example, simple example, sodium plus water, you will give sodium hydroxide. So not only the sodium, all the metals, potassium hydroxide, rubidium hydroxide, lithium hydroxide and all. So they collectively called alkali metals. And the other fellows, group 2 fellows are called alkaline earth metals. This is alkali metals, this is alkaline earth metals. Okay, so among this first group elements, sodium and potassium are most abundant. That means whereas lithium and rubidium, cesium is lesser, very less. This is radioactive and very less. So these are this thing. So it is highly radioactive, so we will not discuss separately, we will discuss this one. Okay. And the other side, if you see what are the other metals of this one, what do you call alkaline earth metals? Lithium, then it will be beryllium. Then this is a 4 plus 8, 12, magnesium, plus 8, 20, calcium, beryllium, magnesium, calcium, and goes on. Okay. Now comes to the, here the electronic configuration, if you see the alkaline earth metals, that will be the 1s2, that means 2s2. 2s2, start with 2s2, 3s2, 4s2, 5s2, 6s2, 7s2 also you can write. They are all alkaline earth metals and the general configuration. Out of this radioactive, anyway, this element leaving, the lithium is slightly separate. Lithium is slightly separate, and here also beryllium will be separate. Lithium and the magnesium, means this, what you call the cross, will have the same type of similar properties. Magnesium and here the beryllium, and then comes to the alumina. Aluminum also we have it. They are called diagonal relationships. See, nice. So because it is having only one s electron, the and they will attain the, by losing the electron, they will attain the noble gas, this thing. So their ionization potential is less. Ionization enthalpy is less compared to, because it is ready to lose the electron. And hydration enthalpy, ionization enthalpy means losing electron. Hydration enthalpy, hydration AION enthalpy, with increasing means lithium is more, then sodium, then potassium, then cesium, rubidium, and then cesium. And there normally this when it is going to the this thing, they are silver white, soft, light metals, because the larger size, their low density, and all these things. There will be small exceptions like the potassium and sodium. The small exception is the small exception. So particularly in the analysis, it is very easy to find out these elements. Particularly, they are more in the available sodium and potassium in the water also. So how to this thing? When you are giving sufficient energy, the atom is getting the gas state, then electron will go to the excited state, and while emitting the radiation, that means while coming back to the ground state, it emits the radiation. That emits the radiation is a particularly, each one will have the crystal clear color, means it is a fingerprint color. That means lithium is having the some nearer to the red color, that called crimson red color. Sodium is very much, sodium upper lamps also available, that is yellow color, and the potassium is a violet color, and the rubidium is red color, red violet, and the cesium is blue color. So these emissions will be measured by the flame photometry normally, or by atomic absorption. That means this electron, first the elements are taken to the gas state, then electron will go into the excited state, then while coming back you are measuring this thing. So flame tests, it can be very easily detected easily. So that will be the normally this thing. Now coming to the, this is only some physical properties, and after physical properties we see chemical properties. This more important is the chemical properties. Lithium means reacting with oxygen. Normally what we are doing, react with oxygen, react with chlorine, means halogens, reaction with nitrogen, like this only we will say for any compounds. Lithium plus oxygen gives lithium oxide. Normally lithium oxide is the Li2, 2 Li, 2O2, 2 is 4 Li it is required, and O2, alright. So 2 Li2, it is a lithium oxide. Then sodium is similar. Sodium is also similar, gives sodium oxide. Here there is no this thing, but one more sodium will be forming, that is called sodium peroxide. Sodium peroxide also will form. So whereas potassium and rubidium, cesium, they will also follow this thing, but their metal state will be normally one. Particularly potassium, if we are coming, potassium forms superoxide, that is KO2. Here don't get confused. What is the valency? If somebody asks oxygen state of the potassium, you should not write plus half or something. Here oxygen is having the different state, that is the minus half, whereas potassium is only plus 1. It is a superoxide. So potassium is no change in potassium, it is a superoxide, that is called KO2, particularly this thing. Whereas the they reacts very, we already told, they reacts very tremendous, means vigorously with the water. Metal plus water gives metal hydroxide plus hydrogen gas liberation. So in this particularly sodium and potassium are vigorous. So whereas not lithium and other these things. So how to store? Then when if it is reacting with water very vigorously, how to store? They will be stored in kerosene. They will be stored in kerosene, whereas lithium is not that much required, whereas particularly sodium and potassium is required to be stored in kerosene, and they react with water and gives hydroxides, very high reactivity, whereas lithium is not that much others are so very less reactive. We'll see the hydrogen reaction with hydrogen, reaction with the halogens, and the other metals reactions and all. Thank you.